Hello all, welcome back to Sri Sai Tech Edu YouTube channel, Read, Lead, Success. I am dealing with the subject Network Analysis and Control Systems. Already I have uploaded Module 1 to Module 4, all the topics in my channel. If you have missed out, please do check out. In Module 5, we have 4 chapters. We will study one by one chapter. Today in this video, we will see root locus technique and what are the concepts under root locus technique. Root locus technique. Under this, we have studied 4 concepts, that is main introduction, then root locus concepts, construction of root loci, rules for construction of root locus. In this, we will see only the concept introduction and root locus concepts in this video. Introduction. The root locus is the locus of the roots of the characteristic equation of a closed loop system in S-plane as a given system parameter. Usually the open loop gain is varied from 0 to infinity. Root locus means what? Is a locus of roots, different types of roots of the characteristic equation of a closed loop system in what? S-plane. You know there is a S-plane and imaginary axis plane, S-plane. This is S-plane, right? In S-plane, you will point the holes and zeros, right? Of a closed loop system for a characteristic equation, these locus of roots in S-plane of a closed loop system in the S-plane as a given system parameter. Usually what? It is open loop gain K is varied from what? 0 to infinity. So that is called root locus. It is a powerful method of analysis and designed for stability and transient response of the control systems. It is a powerful method of what? Analysis and designed for what? Stability. For stability, we can use this method, root locus technique, transient response of the control systems. It gives information about absolute stability as well as the relative stability of a system. It gives what? The absolute stability as well as the relative stability of the system. It clearly shows the ranges of stability, ranges of instability and the conditions that cause the system to break into oscillations. What root locus technique will show? The stability, ranges of stability, instability and the conditions that cause the system to break into oscillations. It can be used to solve higher order algebraic equations. If the equations are of high order, we can use this technique. The value of k for a particular root location and the roots for a particular k can be determined using root locus. In designing a linear control system, the root locus method is very useful since it indicates the manner in which the open loop poles and zeros should be modified so the response meets the system performance specifications. It is useful why it indicates how open loops and zeros can be modified on the plane so that the system performance will increase. To understand the concepts of the underlying the root locus technique, consider the simple second order system shown in figure. This is a second order system. So this is a second order system where you can see the system is given in such a way that k by s into s plus p is the g of s and the feedback is what? Minus 1 is given. Okay, this is the second order system where k and b are what? Constants. As we know, k and b are what? Constants. The open loop transfer function has two poles, one at the origin and other at the b. How? See, characteristic equation is nothing but a denominator 1. So s into s plus b should be equals to 0. As you can see, 1 will be s equals to 0, 1 and s plus b equals to 0 means s is equals to minus b. Okay, so these two are the poles. Okay, the closed loop transfer function of this system. Closed loop transfer function is nothing but what? Output by input. S of s by r of s is what? As we know, g of s by 1 plus g of s into h of s according to the transfer function. As here it is minus, we will consider here plus. After considering, we will write the g of s and substitute h of s as 1. You will get what? K by s square by s square plus bs plus k. The characteristic equation of the system is what? S square plus bs plus k equals to 0. right? Then s square plus bs plus k equals to 0 we got. This second order system is always stable for all positive values of b and k. If b and k are positive values, then the system is stable. If it is negative, as we know that it is not stable. But its dynamic behavior is controlled by the roots of the characteristic equation. Dynamic behavior will be depending on what? The roots of this characteristic equation. So, and hence in turn, by the magnitudes of b and k, since roots are given by, how you can find roots of a quadratic equation like this, second order, third order, second order equations, you have a formula for that, that is minus b plus or minus square root of b square minus 4ac by 2a. Okay, if you substitute, you are going to get this only, minus b plus or minus square root of b square minus 4ac by 2a. Here b is what? B itself, and a is what? 1 as it is, it has a coefficient of 1, and c is what? K. So if you substitute these values, you are going to get for a finalized form like this. That is nothing but s1 and s2, two roots you are going to get. From above equation, we can observe that roots of the characteristic equation change as any one of the system parameters b or k varies. If b or k varies, the roots will change. Consider that b is constant and k is variable. We are considering that b will be constant of some value and k will be varying different values. As the open loop gain k is varied from 0 to infinity. Open loop gain k is varying from 0 to infinity. The roots s1 and s2 describe a loci in the s-plane. The root locations for various values of k are as follows. See how root values change. We are going to discuss based on this roots what we get in the equation. Okay, 0 if the k value is between what? 0 and b square by 4. Then the roots are what? Real and distinct. When k equals to 0, the two roots are s1 is equals to 0. Okay. If k is equal to 0, what happens? s1 will become a is equals to 0 and s2 will become minus b. If you substitute in the place of k 0, then you will get s1 as 0 and s2 as what? Minus b. So they coincide with the open loop poles of the system. So when k is equals to b square by 4, when k is what? B square by 4 if it is, then the roots are real and equal in value. That means s1 and s2 will be minus b by 2. If you substitute k value as b square by 4, then you will get s1 and s2 as minus b by 2. Then if b square by 4 is less than k less than infinity, if k is greater than b square by 4 and less than infinity, the roots will be complex conjugate with real part. Okay. That is equals to minus b by 2. That is unvaryingly real part. Unvarying real part. You will get as minus b by 2. So we are giving different values so that we will understand based on the b and k values only the roots are depending. Either real distinct or real and equal or complex conjugate. Like that, based on the b and k values, we are going to get to know. Understanding? And that too we are varying the variable k. We are keeping b as constant. As told in previous line, b is constant and k is what? Variable. The root locus with varying k is plotted in figure. As we have seen just now, by changing the k values, we got some values. B is constant. The loci given the following information about the system behavior. You can see here when k is less than b square by 4, then when k is equals to 0, k is less than b square by 4, and k is equals to 0, and k is equals to b square by 4, and k is greater than b square by 4. As when there is a k greater than b square by 4, we are getting on the imaginary axis, this axis. Okay, like that they have plotted the graph. Okay, we'll see how this graph is explained. The root locus has two branches starting at two open loops, that is s is equals to 0 and s is equals to minus b when k equals to 0. See, when k is equals to 0, s is equals to 0, it is starting from, this is this is imaginary axis, and this is what is the s plane. Okay. So when you see, this is the real part and this is the imaginary part. This whole thing is a S plane. As you can see from here, as you know, this is what? 0th point. When k equals to 0 and k equals to 0 minus b. Okay. When k equals to 0, S is equals to minus b. This is what starting. The branch is starting at 2 open loops. Then as k is increased from 0 to b square by 4. When it is increased from 0 to b square by 4, that is k is greater than b square by 4, the roots move towards the point minus b by 2. The roots will move toward minus b by 2, comma 0 from opposite directions, from this and this opposite directions, both real, negative and unequal. Both are what? Real, negative and unequal. They lie on the negative real axis, which corresponds to an overdamped system. As they are on the negative real axis, they are overdamped system. For k equals to b square by 4, when k is b square by 4, the two roots meet at what? S is equals to minus b by 2. As we got previously, at minus b by 2, the two roots meet. This and this will meet at b by minus b by 2 as k is equals to b by minus b by 2. So the roots are real, negative and equal. Real, negative and equal. The two roots becomes what? Equal when it is minus b by 2. Okay. This corresponds to a critically damped system. This corresponds to what? It is a critically damped system. As k is increased further, k is greater than b square by 4. Then the roots break away from the real axis becomes as we are increasing more and more till infinity, less than infinity but greater than b square by 4, as you have seen previously only, previous slide. What it happens? It will break through this real axis and they go to complex conjugate, that is vertical. Okay, vertical they go. Complex conjugate, since the real part of the both roots remain fixed at minus b by 2. The roots move along the line sigma is equals to minus b by 2, that is the real part, and the system becomes under damped. For k greater than b square by 4, the real parts of the roots are what? Fixed. Therefore, the settling time is nearly constant. So here it is fixed and then they go beyond the real axis and break out and go to what? Imaginary. That is nothing but what? Complex conjugate. They become complex conjugate. So when you if you connect these all, it becomes what? A triangle. Understanding? So the root locus shown in figure has been drawn from the direct solution of the characteristic equation. From the characteristic equation they have drawn. This procedure becomes tedious for third and higher order. This is directly drawn from the characteristic equation. As it is second order system, it's easy to draw directly. But if it is s cube, s power 4, s power 5, if it is more than 2, s square order, then it is tedious. It is very tough to do like this. So even scientists who developed the word graphical technique, by using which the root locus can be constructed easily for third and higher order system. Using which the root locus can be constructed. A graphical technique is found for this. How to do that we will see. Consider the single loop feedback system. It is a single loop feedback system, G of s and H of s, and input and output. This is the feedback. Then its closed loop transfer function is, you know that, G of s by 1 plus G of s into H of s. Characteristic equation is what? 1 plus G of s into H of s equals to 0. The roots of the characteristic equation, that is the poles of the closed loop system, occur only for those values of s for which G of s and H of s is equals to minus 1. The roots of the characteristic equation, that is the poles of the closed loop system, occur only for the values what? When G of s and H of s will be equals to minus 1. Since s is a complex variable, the equation G of s and H of s is equals to minus 1 is converted into two Evans conditions. There are two Evans conditions which are very important. What is that? Modulus of G of s into H of s is 1. Means G of s and H of s, if it is negative value also, you will consider as a positive. Modulus means negative and will not consider it as negative, will consider it as positive. So modulus of G of s into H of s is equals to what? 1. The angle of G of s and H of s, you have a formula called plus or minus 2q plus 1 into pi, where q equals to what? 0, 1, 2 and so on. Plus or minus 2q plus 1 into what? Pi, where q equals to 0, 1, 2. Then these conditions imply that roots of the characteristic equation 1 plus g of s into h of s equals to 0 are those values of s for which the magnitude condition g of s into h of s equals to what? 1. And the angle condition is what? This. The same they have repeated. Then are satisfied. They should satisfy this both. Okay, they should satisfy these both conditions, any of the characteristic equation. These conditions are not independent of one another and one implies the other. They are not independent of one another. Okay, they are not independent, they are dependent. That is, one implies the other. Therefore, a plot of the points in the complex S plane satisfying the angle criterion, that is, this one, is the root locus. The angle whatever we are finding, no, this angle, this is what? This is what? Root locus. The value of gain corresponding to a root, that is point on the root locus, can be determined from the magnitude criterion. The root corresponding, that is a point of root locus corresponding to a root, the value of gain corresponding to a root, that is the point on the root locus, is determined from what? This is used to find the angle criterion. Okay, then this is for root. So the root locus can be quickly drawn by checking the angle criterion at various points of the S-plane. Angle criterion as well as the pointing, exact point using this magnitude g of s into h of s equals to 1, we can find the various points or the roots which are on the S-plane. That is what, for that, why we find roots? Just to know the stability, whether it is stable or not stable. Okay. Consider, for example, the feedback system of figure 6.3 with whatever we have seen, 6.3, no, there is a g of s and input, output, and here one summing point, h of s, just a second, h of s, okay, h of s, h of s, this is what this diagram we have seen, this is c of s and this is r of s. Okay, if you see here, example feedback, g of s is equals to k into s plus a. What they have given for this? G they have given as, g of s is given as k into s plus a by s into s plus b. H of s is what? In the place of feedback system. So characteristic equation will become what? As I told in previous module also, the characteristic equation is nothing but what? 1 plus g of s into h of s equals to 0 is nothing but the characteristic equation. G of s is what? This. You will put that and h of s. So 1 plus h of s is what? Here 1. So 1 plus g of s is equals to 0. So the open loop transfer function g of s into h of s has two poles. That is, s is equals to 0 and s is equals to minus b. As we can see, s into s plus b plus 1 equals to 0. So the characteristic equation, if you see, you will get what? When s is equals to 0 and s is equals to minus b as what? Two poles, and a 0 at s is equals to minus a. Why? Because in the numerator also you have s plus a. So s will be equals to what? Minus a. So as shown in figure 6.4. 6.4, this we will see in the next slide how it is exactly. First you understand what it is. The angle criterion for the root locus is, you know that angle criterion is what? Even has given angle g of s into h of s. So angle g of s is what? S plus a by s into s plus b is the angle. What you should take? Only s in plus a by s plus s into s plus b you should take. That is equals to what? Plus or minus 2q plus 1 into pi. Q equals to 0, 1, 2. So in the place of s, what you should do is substitute sigma plus, that is the real part and the imaginary part in the equation 2. What happens? In the place of s, sigma plus j omega plus a, sigma plus j omega plus b, which will substitute. So in the previous slide we got till what here. Then what we have, therefore tan inverse omega by sigma plus A minus tan inverse omega by sigma minus tan inverse omega by sigma plus B equals to minus pi watt. How you got this? I have made it clear, which is not there in textbook. So I made it separately. How this, from this you got this. How means, in angle, if there is a numerator and denominator like this, numerator and denominator, what it happens is you can minus them. That is angle sigma plus j omega plus A minus, in denominator what you have, sigma plus angle sigma plus j omega plus sigma plus angle sigma plus j omega plus B you have. So what happens? Sigma angle sigma plus j omega plus A minus angle sigma plus j omega. This minus goes to this also, multiply it, minus angle sigma plus j omega plus B. Now apply the formula for the angle of complex number. Complex number, how it is? Z is equals to x plus jy. That is equals to theta is equals to tan inverse of y by x. This y imaginary part by real part you will do. Tan inverse of y by x you can do for a complex number. As all are in the complex, what you can do? In the place of angle sigma plus j omega plus A, you can write tan inverse x by y by x. This is what? This is y, which is y. Omega is y. The imaginary part is what? Y, which is beside j. Omega by, you are left with what? Sigma plus A, that will be x. Again sigma plus j omega, angle sigma plus j omega you can write what? Tan inverse of x, y by x. Y is what? Omega by sigma. Here again omega by sigma plus B. Like that you can write. Putting all together, you will get tan inverse omega by sigma plus A minus tan inverse omega by sigma minus tan inverse omega by sigma plus B equals to minus pi. All angles will be equals to what? Every time minus 180. Okay, minus 180. So minus pi you need to equal. Understanding? You know whether in a when you take like this plane from here to here is 180, no? 180 degrees. So when you are taking the points on it, the different angles, then it becomes equals to what? Minus pi. Like that you should take. You got this and this same, no? Now you understood how this to this has come. So now after this, what you should do? Tan inverse. You can take all this, what? Only the tan inverse omega by sigma plus A, this pi if you take left side and these two on the right side, you will get in this form. Okay, taking tan on both sides. What you should do? You should take tan on both sides. When you take tan on both sides, what happens is if you see this is in the form of, when you take tan on both sides, what happened? I'll show here. If you take tan on both sides, it will look like this. And here also if you take tan, it looks like this. Just a second. Here it should be like this. Tan on both sides. This pi also need to be included in the bracket. Okay, tan on both sides. If you see, this is in the form of tan of A plus B. This is A, this is B. This is also in the form of tan of A plus B. Tan of A plus B formula is what you know? Tan of A plus B formula is tan of A plus B formula is tan A plus tan A plus tan B, tan A plus tan B, tan A plus tan B by 1 minus tan A tan B. 1 tan A plus tan B by 1 minus tan A tan B. Okay, if you see here, tan A, tan inverse omega by sigma. What happens? Tan and tan inverse will get cancelled. You will get omega by sigma plus tan inverse B. That is omega by sigma plus B. Tan and tan inverse will get cancelled. You will get omega by sigma plus B. 1 minus tan A tan B. 1 minus tan A is what? Omega by sigma plus B. Here also tan and tan inverse will get cancelled. Right side also it is in the form of what? Tan of A plus B. Tan A plus tan B. As here pi has no tan inverse, you will write directly tan A. Then tan B. Tan B is what? Tan of tan inverse omega by sigma plus A. You will get tan and tan inverse cancelled, omega by sigma plus A. 1 minus tan A and tan B. Tan and tan inverse will get cancelled, again you will get omega by sigma plus A. That is equals to, if you see here, omega by sigma plus A. Omega by sigma plus A. As we know in trigonometry, this tan pi is what value is? 0. Okay, when you substitute tan pi as 0, here also tan pi as 0, what happens? 0 plus omega by sigma plus A, 1 minus 0 into sigma plus A. Then you are left with what? Omega by sigma plus A. Then omega into, that is omega into sigma plus B. Then they are taking left hand side, what is that? No? They are taking LCM. That is omega into sigma plus B plus omega sigma by, you will get sigma into sigma plus B. Total by, then sigma into sigma plus B minus omega square. Again sigma into sigma plus B, sigma into this denominator gets cancelled after LCM. Okay, then you are left with what? This equation. Okay, again what you will do, you will multiply inside, you will get 2 sigma plus B by sigma square plus sigma B minus omega square by 1 by sigma plus A. This omega, this side omega and that side omega get cancelled. This side also you will get 1 omega, this side you will get cancelled. Then 2 sigma, you will multiply these two now. 2 sigma square plus 2 sigma A plus sigma B plus AB is equals to sigma square plus sigma B minus omega square. Okay, when you see here, again you taking this to left side, what happens? See, 2 sigma square minus sigma square is sigma square. 2 sigma A and minus this sigma B and this sigma B get cancelled. 2 sigma A, this minus omega square will be omega square. This AB, if you take right side, you will get minus AB. Okay, you will get a equation like this by changing left to right and right to left hand side equations. Then sigma square plus 2 sigma A is equals to what? Sigma plus A square minus A square. Here what I have done here is, I have did this so that you will understand how the next steps are done. Why? Because in textbook directly they have given this equation. If I directly give, you will not understand. So what I did, first what I took is sigma square plus 2 sigma A as the separately. So 2 sigma A. This how you can write? Sigma plus A whole square minus A square. Again if you do this, if you expand this, you are going to get this value only. This value only. How I will show here if you want. See, sigma plus A square is what? A plus B whole square. Sigma square plus A square plus 2 sigma A minus A square. This A square and A square get cancelled. Again you are left with what? Sigma square plus 2 sigma A. Sigma square plus 2 sigma A. So sometimes you need to manipulate the equation so that you will get the correct answer. So you will do like this, and so adding omega square. Again you will take this back to this way, you will add here. So sigma plus A whole square minus sigma square is nothing but this value only. You will add that plus what? Omega square again equals to minus AB. Just you are adding this to this equation. Then now move A square to the other side. So when you multiply inside, this sigma A square plus omega square if you do, and this A square will come to this side. So A square minus AB. Now taking square root on both sides, what happens? Sigma plus A square, sigma plus A whole square plus omega square, square root of A square minus AB whole square. Why this is taken is because it is in the form of x square plus y square plus r square. The equation for circle, I hope you know, that is x square plus y square will be equals to what? R square. So only it is done like this. To get this form only they did this manipulations. So x square is sigma plus A whole square plus omega square, that is y square, and if you this square root and root get cancelled, again you will get A square minus AB only. So you can write as what? To want in the square term, you will take square root and whole square. Nothing but again cancellation will happen, then you get this equation only. Okay, as in the form of equation you want, that is x square plus y square plus r square, you are changing this right hand side in this way. Okay. Then to draw like this as a root locus plot system, we are taking in the form of x square plus y square plus r square. As I told in equation also, in diagram it is shown, I told, no, that is when k is equals to minus a, s is equals to minus a, s is equals to minus b, and s is equals to 0. This is the way how the points are maintained. See, this kind of circles are there, no, those are zeros. These into marks are there, no, what? They are poles. These into marks are what? Poles. Okay, keep that in mind. Now what we will do? Sigma plus a square plus omega square, that is equals to a square minus ab, that you got as this equation. That is nothing but x square plus y square plus r square form. Equation 6.4 is the equation for root locus in S-plane. This is the equation for root locus in S-plane. It is a circle. I told you, as it is circle, x square plus y square plus r square. So at minus a comma 0 is centered at minus a. This is the minus a. It is centered at minus a at the 0 of the open loop transfer function. And the radius is what? This is the radius, r square, root of a square minus ab. Okay, understanding? Minus root of a square minus ab. Then the root locus is drawn in figure. How? Just see here. This is 0. This is minus a, minus b. Okay, and minus b. If you see, this is the center. Using this center, they have drawn a circle. This is k when it is infinity, from 0 when k equals to 0 and k equals to infinity. These points are moving away like this. From here to here it is going, from here to here it is going, and from here to here, and from here to here. And this is what? Xi minimum, damping ratio. That is the angle. This is the what? Angle. And this is what? This is the tangent rod, this is the angle, and this is the radius. Like this we need to draw the root locus. Understanding? For what? Then construction of root loci we are done with till here. Construction of root loci and rules for construction of root locus separately we will see in the videos in the next video. For now I am stopping the video. Thank you from Sri Sai Tech Edu YouTube channel. Read, lead, success. Keep reading.